All right, folks, we're going to work on our packet tracer labs, and we're going to work on this first one here, blinking an LED using Blockly. And so I'm going to click in here just to give you a look at the assignment. And so we're going to be using packet tracer as we have been, but we're also using what we call a block style programming language. Have any of you ever done this thing called Hour of Code? Has anybody ever heard of that? Has anybody done any Scratch programming? Okay. Okay. Yeah, and if Scratch is really, it's a block level programming tool that it kind of gets morphed and used in a lot of different formats. But basically, so instead of writing computer code, you have like these little modules and blocks basically that you can grab and drag and drop and move around and type different values into instead of writing code, but you still kind of execute this programming language. And a lot of people who don't know how to code find this a lot easier to use than writing like a statement of code where you might make a mistake. And so this is the language that we're basically going to use. Once you have that document open, you probably want to strategically put it up on the screen so you can read it. I have mine over here on screen number 2. And so I'm going to use that as my guide, even though I'm not looking at it right now. And I'm going to have to reshare my screen here. So this video has been running with my big old face up on the screen, which I'm not really a fan of, by the way, on my YouTube videos. If you haven't noticed, I'd much rather show my screen. So make sure you pull down that document and then bring up Packet Tracer. So go to your start menu and go ahead and launch Packet Tracer. Get that up and running. All right. And we do have a blank canvas here, so we're starting from scratch, which is exactly what we want. And we're going to start by just looking at the first set of instructions here. So it says launch Packet Tracer, done, right? And what they want us to do is to pull some devices onto the screen. So they're going to take us first to the components area. So remember, they have kind of like this double layer tool panel down here. The top row, the third item over is components. So you guys see where my mouse is here. And you know what? I always like to do this too. So I have this spotlight tool right here. So you can see my cursor a little bit better. But it's this icon here. The components tool is the first one that we want. And then from the components panel, we want to pull up what we call an MCU board and drag that on the work area, right? So components down here, see where my mouse is? And then once you're in there, you want to pull up MCU board and then pull that up onto the panel. That's your first step. Then we're going to go down to the bottom panel, and you're going to notice they have 3 different things on the bottom. So they have boards, actuators, and sensors. We want an actuator. And then in this panel here, you're going to notice the LED bulb. We've used this before, right? So we're going to take an LED and pull it up into the workspace. Doesn't really matter too much where these end up on the screen. I know like in the document, they have them, like the position is reversed. And yeah, that's really kind of hard to see, generally speaking. The reason I'm not zooming in though, for at least right now, I mean, because I can zoom in, but I find that the zoom in function on this is really kind of pretty darn clunky. So I'll try to go with it if that's helpful for you guys. But I also am going to be doing most of my work in the little panels that we pop up. All right, so once you have the board and the LED light on here, the next thing we're going to do is we're going to click on the connections icon. That's the lightning bolt. So that's down here. You guys see that? Click on the connections. And as we've done before, we're going to use an IoT custom cable. It's the second last icon, or it should be up there. And notice how I hover over it, and then down here it says IoT custom cable. And then we're going to click, and we're going to create a connection from the MCU, port 1, so D1 on the MCU, to port D0 on the light. Now, I think I talked about this last time, but if you go up to the options menu here, up at the top, and click on preferences, they do have this checkbox right here that I'm turning on and off that shows always show port labels in logical workspace. I always like to have that turned on because it shows you your connections, visually in the space. And so I can see D1 to D0 just to make sure I have them correct. See that? All right, quick question. Everybody okay so far? All right, resuming the recording. Yes, Nicia. Oh, to get the label on there, just go up to the options menu, choose preferences, and there's this box right here. Always show port labels in logical workspace. If it doesn't show that, it could be because you're active inside of something already, in which case you'd have to close out the window that you have active before you trigger it. Welcome. All right, so now we're gonna jump over to the board, and we're gonna double click that board, and it brings up this panel, and I'm gonna try to move it off to the side so you can see it, right? So I just double click the board and it brings up the panel. And we're gonna click over to the programming tab. All right. And then if you don't see all this stuff here, so it's possible that you might not be seeing it, there might be an advanced button down in the corner here. So if you're not seeing the programming tab, so maybe you're here or in one of these other tabs, but there's a button down here that says advanced that shows you all the rest of the stuff. You guys all good? All right. So now we're gonna just move on to the next instruction. So if you're following along, that was step G, by the way. And now we're going to step 2A. Bless you. All right. Now, right up here, we're now gonna click on this new button. You guys see where my cursor is? There's a button that says new. And they want us to name it. So let's give it a name. They want us to call it blinking LED. And then we want to choose the template, and I'm going to hit the drop arrow here, and I'm going to tell you that the one that we're looking for is going to be at the very, very bottom. But I want you to notice as you kind of scroll through here that you can put in a whole bunch of different types of languages. A lot of them are Python, some are JavaScript, and some are visual, which means those are the block coding is what visual is. So it's the Blockly tool or the Scratch tool. So at the very, very bottom, we're looking for this one. It says blink visual. All right, so once you have that selected, then go ahead and click create. And then what's going to happen here is it loads up a pre-created program called main visual. And if you double click that, it'll open up the block program that makes it blink. And the one thing I want to show you right away is in the instruction set. I want you to look at this because this is a little bit different than the way it used to be, right? This is one of the things that Jerry and I were struggling with earlier as we were kind of putting this together. That these values here say 1 and 0, 1, 1, and 1, 0, where the ones inside of our visual coding language say 1 and 1023. Okay, so here's what I want to do. I want to go in here and I want to set this first one to say 1. So that's right here. Set that first one to say 1. And all you have to do is click in there and type. And when you're done, just click outside of it and it should lock in. Now, we just basically changed the computer code sort of visually, you know, because it's a visual language. Yes, Chris?
Yeah, let me put one in.
Is your num lock turned on?
Yep. Yeah.
Yeah, let me come and take a look. This is kind of interesting because Chris accidentally, he went to like type in a number here, right? But instead what he did is he hit delete or whatever, and it deleted the whole object inside that window, right? So if that happens to you, by the way, you can go to a different one of these, highlight it so it's got the yellow highlight, then you can right click, duplicate, and see how it brought up another one right here, and then you can just drag and drop it into the space. Right. So this is actually one of the tricks here, because we're going to do a whole bunch of this, like duplicating and dragging and dropping. Yeah, exactly. And they're puzzle pieces that fit inside. So like, you know, like what fits because of its shape. Exactly. Yeah, a good point. All right. So once you have it set up like this, go ahead and hit the run button. And if you're smart, you can move the panel, you know, over so you can see like the light in the board. And I'm going to hit run. And what you're going to notice is nothing is happening. Right? All right. So then hit stop. And now go back and change this number back to 1023. 1023, which is its highest possible value. And then hit the run button and then watch the light come on and off and on and off. Oh boy, that's very exciting. Ooh, ah, exciting. All right, we'll come and take a look. All right, so everybody got that to work so far? Let's see what you see. We have them in different screens, so you'll have to hit run here. Yeah. You have them on different desktop spaces. You can drag that desktop space into your other desktop space. Yeah, we have them on those are less than your people. I think it's I think it's a 3-finger flick. Yeah. Yeah. So it's on the Mac person too. See, like on a Mac, we take that for granted that you work on multiple desktops all the time and you don't even think about it. By the way, folks, you can do that on Windows 10 and 11 too, but most Windows people don't even know it, right? So if you have a Windows laptop, 3-finger flick, here's your, yeah. And notice I'm working on desktop number 2 right now, right? Why? I'm not sure, just because I am. That's why. But Nicia was running, like, more common on a Mac is every time you open a program, especially if you go full screen with it, that it usually goes to its own desktop. All right, so I actually recorded all that, so I'm gonna have a little bit of dead air in there, but whatever. Yeah, but hit that run button and hopefully your light blinks on and off, which is a success, all right? Yes, sir. All right, so if you got that far, I do want you to notice in the document, so I kind of expect you to, you know, answer these questions too. So this one says, Click run, does the LED blink? Hopefully it did. If it didn't, then you figured out why it didn't and fixed it. And we had a couple of those scenarios, right? And once again, if it doesn't work, don't freak out. There's always a fix, right? And if it wasn't blinking, why was it not blinking? Yeah, it's either the wrong code. Well, we had changed the code to 1 here, and this is kind of interesting, but the possible values that go into these spots are anywhere from 0 to 1023. That's 1024 possible values, right? So what that tells you is 1023 is basically on and 0 is off. Now, I want you to think about this really carefully. That's a digital command. In the digital world, there's really only 2 values, off and on. That's it, right? So if we gave it a value in between, it's kind of irrelevant. If it's like really low, it's basically 0. If it's really high, it's basically on. And that's how digital works. And I think it's kind of an interesting thought. Now, what we're going to do in the upcoming section is we're going to start switching to an analog write command to show you that there's 2 different kinds. The difference with an analog command and a digital command is the fact that an analog command, you can change the power level. You can have an in-between. So it's not on or off, it's off or how on do you want it, kind of like a dimmable light. So it's kind of an interesting thing. So what they're going to have us do here, and I'm going to bring the instructions back over, is they're going to have us basically switch these 2 commands here to analog write commands. And I want to show you how to do this because it's kind of, I'll just put it this way, a little finicky is a polite way to say it, you know? Not that you guys wouldn't be able to figure it out on your own, but it's so much more helpful if you have somebody just show you. Now, without altering what we already have, I'm going to add the stuff that we need. So I'm going to click on here where it says pin access in this little panel. You guys see that? Pin access. And you'll notice that we have digital write, which we've already been using, but now we want the analog write command. You notice how I hover over it and it turns yellow? You can just click and drag and just bring that over here and just drop it into an open spot. Now, drop it into an open spot on purpose because that's kind of a safety zone. I'm not changing the way the blocks are right now. This is a little quirky, right? So the tool's got a kind of a certain way that it works. And what we're basically doing is we're going to replace the digital writes with analog writes. So I'm going to take this highlighted yellow analog write, I'm just going to drag it. I'm going to put it either right above or right below the digital write. Either above or below is fine. Once it's in position, you're going to notice that it's attributed to a certain slot number, right? Now, on the board, before we were using slot 1, we're still going to use slot 1. So we got to change that first number to 1. Then you're going to notice the second thing is blank. And so what I can either do is I could copy this one that says 1023. Okay, so how do I copy it? First, I click and highlight it, make it yellow. Then right click and duplicate instead of copy, right? You notice what it did? It just kind of dropped it on the screen here. Then you just want to click and drag and drop that into the box. All right, now once you have that done, now I can click on this analog write thing again. The whole block turns yellow. And then I'm going to right click and duplicate that. And it creates a copy. And it seems like it's putting it in the block, but it's just floating there. And I'm just going to drag it and put it down here, right below the delay. And then I'm going to come in here and I'm going to change the value to 0. Okay, so the next thing I'm going to do is now I'm going to click on the digital write, highlight it, make it yellow, and then I'm going to use the delete key on my keyboard to get rid of it, right? Digital write, highlights yellow, delete key to get rid of it. All right. Now, we deleted both of the digital rights, and we've basically replaced them with analog rights. Okay, so here's what I'm gonna do. I'm gonna go ahead and run this so you guys can watch it run. And here's the light on and off, just like before, right? Now I'm gonna stop it. To show you the difference between an analog and a digital right, I'm now gonna come into this value, the 1023 one, and I'm gonna change it to like, I don't know, 200, much smaller number. And then I'm gonna run it and watch how the light is much dimmer. You guys see that? It's not as bright of a green. So I'll switch it back to 1023, just watch. And see how bright that is with the 1023? And so this is kind of interesting because basically what the analog right does is it allows you to set a power level anywhere between 0 and 1023, and that's how much energy goes to the light, and it makes the light that bright. All right, so I'm just gonna leave it here up on screen like this. Okay, now we're moving on to part 2, and we're gonna so I'm just gonna pull the instructions over here for just a second. So we're gonna add another board and another light to this setup. So I want you to follow that, but when you add another light, it's not the same light. There's a different light a couple over that's a RGB light. And so let me just show you the process of this one by one. And I'm gonna set up my board and light right below these so I can see them, you know, compared to the old one. I'm gonna close this panel, but let's go back down here. We're gonna go back to the board. So that's under components and boards. So grab another MCU board and just drop it here. And then we're gonna go to the actuators. And then, okay, so here's our first LED light, but that's not the one we want. We wanna go 3 over to the right, and it says RGB LED. Now, if you guys are kind of like in the know with the terminology, what does RGB stand for? Red, green, blue. Now this is really kind of interesting because when we look at our computer displays, every pixel on our computer screen is controlled by a little LED light like this that can do all 3 colors. So when we put stuff on a screen, it's a combination of red, green, blue in various strengths of those 3 colors that give us the colors in our display. Now, it's pretty kind of mind-boggling because like a display like the one I'm working on right now, this is 1920 pixels across by 1080 pixels tall. Now, you can do the math on that. How many pixels does that make on the screen? A lot, right? And all of those pixels are being controlled and changed. If your refresh rate's at 60 hertz, 60 times a second, each one of those lights is updating. If you're a gamer, right, and you're running at like 144 hertz or something, right, it's that many times a second that each one of those lights is being changed. I want you to think about like what that takes from a processing standpoint, like you're moving around in a game or something, or you're just like turning your head to look or whatever it is, and your screen is updating all the pixels on the screen. That's mind-boggling, you guys. We're just trying to turn one light on and off, right? What kind of programming would you have to do to control all those pixels at the same time? Now, there's a programming challenge, right? There's one that we have already overcome though, so we're just learning the basics right now. But that's the difference with this LED light. And I want you to notice that this LED light has 4 connectors. So red, green, and blue have their own separate control path on these. So we have to wire it up a little bit differently. So when you get to the connections part, which is step B, we are gonna hook up basically 3 separate connectors to this RGB light. All right, now there is this panel here. So like if I click on the light and scroll down, and they're showing this in the instructions, and it says the specification. So it shows you that this device has 3 input slots. A0 controls red, A1 controls green, and A2 controls blue. All right, so that's important to us for doing the programming, right? So we know which thing we're sending it to and which color we're turning it on and off. You guys are catching my drift here. I'm going to close this, and I'm going to go ahead and click on the connections icon. That's the lightning bolt, right? And then I'm going to grab an IoT custom cable, same thing that we've been doing. And then I'm going to go from the board, and we're going to start from the board. D0 is going to connect to A0 here. And then we'll just repeat that process. Custom cable, we're going to go from D1 to A1. One more time. D2 to A2. All right. And this is where the labels are kind of helpful, honestly. All right, so we followed the same process. I'm just going to repeat this. Double clicked on the board. I went to programming. I created a new program using the main, the blank visual template. Double click the main visual, just like we did last time, and brought the block level program up on the screen. All right, now we have a couple extra things that we have to do here, and there's a few different ways to accomplish this. So I'm going to show you both ways. You guys can pick whatever way you want to do this. But with the previous device, we had 1 pin of input to control that light. And so that program assumes a simple LED, and it has a 1 pin slot up at the top, right? Notice that? This one's got 3. So we have to either duplicate these pins. So here's one way to do it. I can click on this pin at the top and then right click, touchpad pick with 2-finger click, right? Duplicate. And now you see it's floating, but I'm going to click and drag and just move it up to the top. That's one way to get it. Or you can go to the pin access menu. That's the second menu on the left here. And notice how they have a pin mode thing right at the top of that. You can just click and drag that out here and then put that way at the top. And so we end up with this. And I want you to notice, you know, the one I dragged from the panel has input instead of output. Is that what we want? No, we want to output. So we want to switch that to output. The other thing that we should keep in mind here is we're controlling 3 different pins on the light, and they're numbered 0, 1, and 2. So I got 3 pins set up here at the top, but it's 0, 1, and 1. No, we got to change the third one to 2. And then to lock it in, just click somewhere off of that. So this is how it should look. 3 pin modes at the top, 0, 1, and 2. All the modes should be output. And hopefully you guys are okay. If you're not, just let me know. We can pause and I can come and help you out with this. All right, Seth, I want you guys to watch really carefully kind of the procedure of what I'm about to do next, because they do want us to switch all the digital rights to analog rights. And basically what they want us to do is create this out of what we have. So we're going to replace the stuff in the middle here with all of this stuff. And I'm going to show you this step by step. So you guys can do it any way you want, but here's the way that I'm doing it. And my strong recommendation is you just follow what I'm doing, right? So if I go too fast, just let me know, no harm done, right? We still got plenty of time in the session here to make this happen. So I'm going to start, because I notice when I'm looking at the finished version that the print thing is going to be nestled inside the other stuff. So I'm going to do that first. Let's just move that print command. So I'm going to click on print right here, right? And I'm going to drag it. Oops, I don't want to take the whole block. All right, so it's not letting me do it. I'm just going to duplicate it. All right. And I'm going to take that and I'm going to put it right here at the top. All right. And then I'm going to come up here and delete this one because we don't need it. Right here. And then I'm going to change the words inside of it from blinking to blinking red.
Yeah.
Yes.
You say you deleted the old block?
Yeah, don't delete it from the right click menu, right? Because that will delete more than what you want. Click it, make it yellow, and hit your delete key.
Second.
Yeah. Yeah, I learned the hard way, the other way. It deletes like a whole bunch of stuff that you, it does, and you don't want, it's deleting all the stuff you don't want, basically. All right. The other thing that we're going to do is these digital rights need to be replaced with analog rights. So if you guys remember how we did that, you can come up to program. Oh yeah, I'm sorry. Pin access, not program, pin access, and then the analog rights are right here. And here's what I'm going to do is I'm just going to drop one on the screen. Right, and I noticed I didn't put it anywhere on the block. I just dropped it on the screen. So I went to pin access, analog right, and pulled it over to the side. In fact, you can grab a couple of them, doesn't matter, right? And what I'm going to do now is I want to replace the digital rights with the analog rights. So I'm going to take the analog right and put it in here. Once it's in position, I'm going to steal the 1023 from the digital right and just drag it up. Right? And then I'm going to click on digital right and press my delete key. I'll do the same thing one more time. So watch. Analog right. I'm going to pull it in here. Now I'm replacing the second one. I want to grab this value of 0, so I'm just going to click and drag it up. And then I'm going to click digital right, press delete. Now, this is kind of a clunky way to do it, right? You know, so like you'll find whatever works best for you. For some people, it's easier to come over here to the pin access and pull a bunch of analog rights over and then change them and pull them into place. For other people, it will be easier to click on something, right click and duplicate. But that's basically what we're going to do here is we're going to replicate this whole structure. And so far, I've replicated the first 4 things. And if you notice, and here, I'm going to draw on the screen here really quick. So there's kind of like a pattern. Here's one block, here's another, and here's another. And so it's kind of like 1, 2, 3, repeating blocks. And so there's some subtle differences, right? So when I will duplicate the print command, but change it to blinking green, and then down here it'll be blue. And then I also want you to notice the slot numbers. These are 0, these are 1, these are 2. So I want you to watch kind of my process here. And it might behoove you to watch and then try to mimic, as opposed to try to do it while I'm talking. And just kind of, you know, piece of advice. Yeah, okay, so here goes. I'm going to switch back to my mouse control here. All right. So first, because I'm kind of repeating this whole block, I'm going to duplicate the print command and then just put it at the bottom. All right. Then I'm going to duplicate the first analog right, put it at the bottom, but I'm changing the slot number to 1. Then I'm going to duplicate the first delay, and I just keep adding them in order. Then I'm going to duplicate the second analog right, add it to the bottom, change the slot number to 1. And then I want another delay, so I'm going to duplicate that, And I'm going to put that at the bottom. So there's a second copy, right? Now I have to do this again. But this time I'm going to change the analog write ports to port 2. And the print command is going to say blinking. Well, this one should not say blinking red. It should say blinking green. And then the next one will say blinking blue. All right, and then I'm just going to go through the same procedure. I'm going to duplicate the analog write, switch to port to 2. I'm going to duplicate the next analog write. Oh, I should have put my delay in there, so I skipped the delay. So I'll duplicate that and I can put it right in between. Then I'll duplicate the other delay, which is 500 milliseconds, and that will go at the bottom. And then this should be close to complete. Now, one way I can double check this is I can just pull this original back over, right? And just go, well, I got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then I'm making sure that the delays, I am noticing my delays are different. Like here they're 1,000 and 1,500, and here they're 1,000 and 500. So I could switch them, so I can make this 1,500. So all the 500s can switch to 1,500. 1,500 milliseconds, by the way, is a second and a half. And then I'm noticing first 2 are zeros for slots, the second 2 are 1s, and then the last 2 should be 2s, and I did have a mistake. And then I was alternating here between 1023 full on and 0 full off. Now, what you guys will discover is slot 0 controls red, slot 1 controls green, and slot 2 controls blue. So if you did this correctly, you should now be able to hit the run button. And if you get your stuff out of the way, let's hopefully get an ooh and an ah here. Hit the run button. There's red, green, blue, and then it'll repeat. Now, another thing that's happening, I don't know if you guys are catching this, but what happens with the print command is the print command prints down here in this part of the window to what we call the console. So this part of the window right here. So every time it blinks green, it says blinking green. Pretty nifty.